Hi everybody, it's just a short video to try to show how positional number systems work. It's something easy if you get the idea, but if not, it could see something quite strange. So let's start. The positional number system is the number system we use. The number system we are used to is based on the 10 base. So we got 10 different number symbols, 10 different number symbols which we call digits. And those number symbols are the symbols going from 0 to 9. Once we reach the 9, we've got no more symbols, so we have to find some way of counting over 9. And here it comes the position. In any positional number system, the value of a number depends on the digit, on the value of the digit, and also on the position. So let's say the symbol 1. The symbol 1 means units. So if you put the symbol 1 in the last position, it will be just the number 1, one single unit. But if you put the same number 1 in the second position, it's not 1 unit, it's 1/10, because in the second position the meaning of that symbol is 10. So one number here means 1/10. If you put the number 3, the number is 3/10, not 3 units. 3/10 because it's not in the last position, is in the first position. The same way, if instead of using the second position you use the third position, then it's not units, it's not tens, it's just hundreds. So one digit, one number 1 here in that position means 100, means hundreds. So with that rule, you could count any number just by using 10 digits from 0 to 9 and any position. So for example, let's say that we want to put the number 111. It means that you have 1 in the position of the hundreds, you have 1 in the position of the tens, and you have 1 in the position of units, of ones. If you increase any symbol, for example 3, 2, 1, it means that you have just 1 unit here in that column, you have 2 tens in that column, and you have 3 hundreds in that column. So the number 321 in base 10 is just 321. That's easy. We are used to it because we count on base 10. And counting in base 10, it means that the position of every digit sets its value. If it's in the 0 position, it's the base 10 raised to the 0 exponent, and the value is 1. Whereas in the first position, it's 10 raised to the first exponent, and the value is 10, so it's tens. Here, in the second position, it's 10 raised to the second exponent, and it is hundreds. So it's why this column is for hundreds. In the third position, it's 10 raised to the third exponent, so it is thousands. And that's why this column is thousands. That should be easy because it's what we are used to. But we could count in any base. Not just 10, we could count in 2 base, in 8 base, in 10 base, in 16 base, or whatever base you want. Those base 2, 8, 10 and 16 are one of the most used in IT, but you can use whatever base you want. If you say that you are using base 2, it means that you have only two different symbols, which are the symbol 0 and the symbol 1. Nothing more, so any value should be calculated by any combination of zeros and ones in different positions. So for example, if you put the symbol 1 in the last position, it has the value of 1 because it's the basis that it's 2 raised to the 0 exponent, and it is 1, it is units. But if you put the symbol 1 in the second position, it is 2 raised to the first exponent, and it is 2. So if you got 1 here in the second position, the value is just 2 because we are counting on two bases. If you put the number 1, the digit 1, in the third position, then the value is 4. The value is 4 because in the third position the value is 2 raised to the second exponent, and it is 4. The same if you put one digit 1 in this position, it's 2 raised to the third exponent, so the value is 8. Doing that, you can count any number. For example, if you want to count the number that start at the beginning, the number 1 is just 1 unit in the last position. But if you want to represent the number 2, the decimal number 2 in base 2, you only have two numbers, 0 and 1. So to represent the number 2, you have to use another position. Put a 0 in the units and just put a 1 in the second position. That means it has a value of 2. So 1 0 in base 2, it has the decimal value of 2. If you count, the second number would be the number 3. It will be 1 in that position and 1 in the units. So 2 plus 1 will be 3. If you want to count further, you can't. You have enough with 2 digits. You can use a third digit. So have 0 units, 0 in the second, and then you put a 1 here. That 1 has the value of 4. So that 1 0 0 is the number 4 in decimal. 1 0 1 is 5. 1 1 1 is 7 because it's 4 plus 2 plus 1. The same what we used to do in base 10, but now the base is 2, so you use powers of 2. The first position has the value of units, but the second is the value of 2, the value of 4, value of 8, 16, and you could go further, 32, 64, 128, 256. Just the powers of 2. And that will be the same with the 8 base. Here you will have 8 symbols, 8 different digits, ranging from 0 to 7. So you will have in the unit 0, 1, 2, till the 7, and then the next number, the number 8, couldn't be represented by just one digit. You need 2 digits. You need to put a 0 in the units and then a 1 in the second position, because in that second position the value of that digit is 8, because the basis is 8 and is raised to the first exponent. So 8 raised to 1 is 8. So this symbol 1 means 8. If I put here the symbol 2, it will mean 2 by 8. So in decimal it will be 16. If I place here the symbol 7, it will be 7 by 8 because it's 3 times 8. So I can count till the last digits, that will be 7. Sorry, that will be 7. 7 will be 56, and if I put here the maximum digit, that would be another 7. It's 63. If you want to express the number 64 in base 8, you don't have enough with 2 digits. Then you will have to place a 0 in the unit, a 0 in the 8, and put a 1 in the third position. That 1 would means 8 raised to the second power, and it is 64. So that one here in 8 base is 64. And a 2 here will be 64 by 2, so 128. If you add here another number, for example the number 1, it will be 128 plus 8, so it will be 136. And if you place here another number, for example the number 2, it will be 138. So you have to add the value of each digit, but multiplied by the value of the position. So if you are counting 8 bases, the position is or 1 for the first position, or 8, or 64, or 512, or 4096. And the same is valid for the base 10 and also for the base 16. In base 16 you have much more digits. We have digits ranging from 0 to F, and the value of each digit also depends on the position. In the first position, that are the units, you can go from the 1 to the 9, and then you have the symbols A that has the value of 10, or B which is 11, or C which is 12, D 13, E 14, and the highest symbol in 16 base is DF, with the value of 15. Again, if you want to express the number 16 in 16 base, you don't have enough with one symbol. You have to put a 0 in the unit and then a 1 in the second position, because that position has the value of 16 raised to the first exponent. So every digit here has the value of 16. 1 here is 16, 2 is 16 by 2, so 32, 3 is 16 by 3, so 48, 4 is 16 by 4, so it's 64. And if you have some digit in the first position, you have to add the value. So if you have here, for example, the number 3, it will be 64 plus 3, so it will be 67. The same way, the maximum value you can express with 2 digits is the value FF, which is 255. If you want to express the number 256, you need to put a 1 digit in that position. So if you put 0 in the units, 0 in the 16ths, and 1 in the third position, that position has the value of 256, so you will have 256. And if you place the number 2 here, it will mean 2 by 256. It is 512. So it's just making any combination of the valid digits for each bases and then multiplying the digit in each position but the value of that position. In 16 base it's 1, 16, 256, 4096. In base 10 is 1, 10, 100, 1000. In 8 bases it's 1, 8, 64, 512. And in binary, in base 2 it's 1, 2, 4, 8. So with a bit of practice it's not difficult to count the value of any number in any basis.